Hey everybody, I got something cool to show you here. So I've been playing around with the overdriven Tate circuit, driving it with the ballast here. Just wanted to get a higher potential going into it. I'll show you this in a second, but the basically the output of the Tate includes a capacitance in parallel that all the rectified charge gets stored into. I've been playing around with shorting that with a shorted gap right across here. You know, some other previous videos showing the effect of how ignore this for a minute, but how a high voltage step-up coil, whether it's an ignition coil or neon sign transformers, these mini ones I have here, or flyback or whatever you want, driving a standard Tesla coil circuit. However, that's not really the part I want to show you. The fact is, I found that I can induce oscillations by collapsing these coils when the output of the Tate gets shorted. Okay, well then I also went on to playing around with, I moved the shorted gap that I had, the manual one, to across this reactance bank that I had in series. So basically the output of the Tate was driving these primary coils, and in series was this 20 microfarad reactance bank that was helping provide the amperage to drive these coils. So then I found that shorting the reactance bank itself also generated a surge in the primary coils, causing the rest of the circuit to operate. So I also noticed that there was such a rapid charge on the Tate storage capacitors that I could discharge that very, very frequently. But then I found that in alternate succession, I can discharge the reactance bank and then immediately discharge the storage bank opposite of each other and get an equal amount of discharge from them. So I started playing around with, there's an interesting effect that comes out of the Tate. There seems to be some kind of I almost call it modulated DC. It's an AC signal that's still kind of noisy coming out of there, in addition to the DC, because your meter will read the DC and obviously it behaves like DC, but when you place an inductance in series, ignore that. When you place any inductance or some inductance in series, the circuit oscillates by itself. Current travels through these primaries, and I get a small voltage output induction, and it is inducing into the big secondary step up, and I'm seeing somewhere around 10,000 volts come out of here at that time. Some little bit of plasma and a light bulb, and I can arc it maybe a quarter of an inch to a ground wire. Definitely some purple plasma coming off of it. But anyway, so I started setting up a defeater circuit to where the directly shorted Tate output was going through a self-defeater buzzer through one side of this relay I got over here. I'll show you, through the normally closed contacts, you know, just like you would normally set up any buzzer or self-defeater circuit, similar to how the room corp operates. However, then I thought, since I noticed that I could do this in succession back and forth, I thought, why not use to my advantage the relay that's already vibrating, since it is a double pole double throw. And instead of using both normally closed contacts, because that would short them at the same time, I'm using the normally open contact on this side. So literally every time the relay fluctuates and switches on, it shorts this one. Sorry, every time it switches on, it shorts this one, and every time it releases and this normally closed makes, then it shorts this one back and forth. And that action causes the buzzer to operate, which turns it back on again. So what you'll see is, you can see on both sides of the relay that we get a nice purple hot arc going on here, and then a real bright white crackling arc from these shorted condensers here happening on this side, and both of them fire the step-up coils, which are in parallel, and are able to activate the spark gap here, which is comparatively tiny, perhaps a quarter of an inch. I'll show you, and it's inducing into the secondary. So here's the setup. This is 120 into the ballast, into the Tate. This is the storage on the Tate. This is the reactance bank here, which is in series, as you saw. This is the double pole, double throw relay, which I'm going to show you when it's running. It's basically wired how, just how you see it in the picture there. These are the two step-up transformers, 5,000 volt, 30 milliamp each in parallel, going to 5 jars, and the big jar over here, approximately 7.5 nanofarads in parallel, and that's just being discharged into the primary, which is inducing into the secondary, which is upside down, hooked to ground on top here, and the bottom is going to the tertiary and the top load. Relay's buzzing away like you would expect. This is very damaging to a relay, which if you see on this side, you can see the purple plasma glow. This is the storage shorting, and then on this side is the reactance bank. You can see it's a much brighter white arc where it's actually cracking. Now the relay wants to fail after a while, but it's not as strong as the shorted gap by itself, but it does allow it to oscillate a lot faster, and the relay's mechanical breakdown is starting to occur when it gets hot. So I can try to show you this real quick. It's almost an inch arc. If I actually use the shorter gap, I can get probably almost 2 inches. Pretty strong there. This whole setup's using 0.17 amps, 18 watts, and once it runs, the power factor hovers between 90 and 98 sometimes. When I hook it with just the coil of the relay directly across the output of the Tate, the circuit still oscillates, and the power factor goes up to 0.98. But I don't get as strong of an oscillation. It's probably only half of what's going on here. I'll have to get it up really close, and it's just a real fine purple arc, whereas this definitely has a lot more current in it. Impulse currents. There's a lot of power potential output from this Tate circuit. Pretty neat that it can discharge them both sequentially, and then I can almost affect the oscillation speed of the relay by almost dampening with this carbon shorted gap here. So it's almost like adding a resistance that's limiting the current able to go through the relay. Not wanting to go yet. This gap has to get a little warm before it really starts to operate somewhat stably. Anyway, that's the point. This relay ain't gonna last very long because it's probably getting pretty hot in there with that purple arc. That purple arc.